Hi guys, we're going to go over the constant acceleration practice problems, aka Robby the Runner worksheet. First thing we want to do is have our equations handy. So let's go over those real quick. We've got our average acceleration equation, which said final velocity minus initial over time equals acceleration. We have the variation of that where we say final velocity equals initial velocity plus acceleration times time. We have displacement equals initial velocity times time plus 1/2 acceleration times squared. We have final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And then we have displacement equals 1/2 times initial velocity plus final velocity times time. So lots of equations to choose from. It will also probably be helpful if we give ourselves a list of the variables that we're going to use or encounter. So the possibilities, there are 5 of them, are acceleration, initial velocity, final velocity, time, or displacement. What you'll find in these types of problems is that at first it's going to seem a little bit hard to choose which equation to use and when. However, the more you practice, the better you'll get at it. And we have a strategy that will really help you out. So step 1 for our strategy is just write out the givens. In this type of problem, there will always be 3, so you're looking for 3 numbers in every problem, okay, right from the get-go. So in number 1, Robby the Runner accelerates from 8 meters per second north to 2 meters per second north. So they give us an initial velocity of 8 meters per second. They give us a final velocity of 2 meters per second. And then it says that he does this over 2 seconds of time. So delta t equals 2 seconds. So we've got our list of 3 givens, which is what I need. Our unknown is acceleration. What is Robby's acceleration? Okay, so notice I now have 4 variables in my list, and I am not given anything else. So what I want to do when I'm choosing the equation is figure out which variable was not mentioned. I don't have any mention of delta x in this problem, right? I'm not looking for it. They didn't give it to me. I don't care about it. And so what I'm going to do is use that missing variable to rule out equations that won't work. Okay, so I can't use this one. I can't use this one. And I can't use this one because all of those have a delta x in them. So that means I can choose either the VF equals VI plus AT or A equals VF minus VI over T. I want to choose the one that already has A by itself. All right, so that made it a lot easier. I narrowed it down to just 2 equations to choose from instead of 5. And then I'm going to just plug in my numbers. Since both the final and the initial velocities were north, I can leave them both as positive numbers. Anytime the direction is the same, your numbers should have the same sign. Okay, so 2 minus 8 on top gives me a -6 meters per second over 2 seconds. I never want to leave this in fraction because I'm using the metric system, so I'm going to divide it out, and I get a -3 meters per second squared, or you could write 3 meters per second squared south. Either would be correct. You do need a direction on there, though, because it's important to note that his acceleration was in the opposite direction of his velocity, which is why he went from 8 to 2. That's why he slowed down. Okay? Okay, for part B, we are going to pretend like we do not know the acceleration. Okay, and we're just going to write down our givens that we have. So again, we know his initial velocity was 8. We know his final velocity was 2. We know the time frame was 2 seconds, but this time we're looking for delta x. Okay, so the one that we don't have in our equation is A, right? And we're going to pretend like we didn't just find A. The reason for that is just that if you happen to find it and you do it wrong and then you use it in the next problem, it's going to mess up the next one too. So right now, while we don't have to use it, let's not. Okay, so if we go up to our equations, this one has A, this one has A, this one has A, this one has A, so that means the only one I can use is that last one. It's the only possibility of an equation that doesn't have acceleration in it. Okay, so delta x equals 1/2 times VI plus VF times delta t. I would, by the way, strongly recommend that you write down the equation in variable form before you plug in your numbers. That's a good way to just check and make sure that you're putting the right numbers in the right spot. And we need to practice that. We need to start practicing that now. Okay, so I'm filling in my equation from my list of givens. And then I'm going to multiply everything, or I'm going to add 8 plus 2 first. So 1/2 times 10 times 2 gives me a positive 10 meters. Or I can write that as 10 meters north, since we've been treating north as a positive direction. Okay, so that's all there is to these. Write down your givens, write down your unknown. You'll have a list of 4 variables. Use the 5th variable that is not in your list to rule out equations that won't work. Plug in your numbers, solve, and then just kind of think through whether your solution makes sense. If it's a velocity or an acceleration or a displacement, always remember you need a number, a unit, and a direction to be counted correct. Hope that helps. Reach out if you have questions.